we'll look at both some of the previous year questions as well as some of the uh, questions which I have brought, uh, which I find most relevant to the current pattern of examinations, right? So let's see. Let's begin the session. Okay, so this is the first problem. Right, 5 burgers, 6 pizzas, and 7 donuts cost 178 rupees. 6 burgers, 4 pizzas, and 2 donuts cost 124 rupees. Find the total cost of 1 burger, 1 pizza, and 1 donut. Let me give you 1 minute for this to think, and we'll just discuss. Okay, so let's discuss now. So now you have understood that in this question we have three parameters or three unknowns, right? The cost of three things are unknown, but we only have two equations. So many problems have been asked of this kind in which it seems that we do not have sufficient information to solve the question, right? And there's an option of cannot be determined also over here, but that's a catch option. Let's see how. So you see, the point to understand is that the objective of the problem is not really to find the individual cost of each of the three parameters, but only to be able to find this expression's value, which is the cost, the sum of the costs of the three things. So sometimes it happens like this, that even though we can't solve for all the parameters, but this can be obtained. Let's see how. Let's define the cost of a burger, a pizza, and a donut as, let's say, X, Y, and Z. Right. In that case, our first equation can be written at 5x plus 6y plus 7z equals 178. Right. And the other equation can be written 6 burgers, 6x, 4 pizzas, 4y, and 2 donuts. So 2z is 124. What I always take care of that whether I am seeing the parameters in the same order, right? Sometimes they do this flip flop thing. They'll give you first statement like this and second statement like 6 burgers, 4 donuts, and 2 pizzas. Then you might do the mistake, right? Okay, so these are the two equations. Now we are trying to find the value of x plus y plus z over here, right? So try to be able to do some kind of combination of the given equations and be able to find this. Means maybe multiplying the given equations with some constants and maybe adding and subtracting the equations might help us reach to the desired result. Basically, we want the value of x plus y plus z, right? Okay, so there is obviously some hidden trial involved over here, right? For example, let's say I double this equation, 5 into 2, 10. Then subtract this. 10 minus 6 is 4. Double this, 6 into 2, 12 minus 4, 8. 12 minus 4 is 8. So the coefficients are not the same. We want the same coefficient, right? Okay. But if I do like this, 5 into 2 is 10. 10 plus 6 is 16. 6 into 2 is 12. 12 plus 4 is also 16. That gives me some confidence. Let me try with Z also. If I do the same thing, which is 7 into 2, 14, and then plus 2 is 16. A little bit of hidden trial is involved, and you are able to get that if I double this first equation and just simply add then the two equations, right? So therefore we are able to get that 16 times of x plus y plus z we get as a number, right? 16x, right? 10 plus 6, 12 plus 4 also 16, and 14 plus 2 also 16. So double of 178, 356 plus 124, that adds up to 480. Perfect. 480, 16 into 30. So our value of x plus y plus z is coming out to be 30 rupees, right? Option A. So that's how we can sometimes, as you can see over here, get to the desired result, right? despite not being able to solve x, y, z individually. Right. Now you might say that, okay, what if it does not strike me? What if I cannot do this hidden trial and reach to the conclusion that this was the exact process to double the first equation and add with the second equation, right? It's quite possible that you might struggle to reach there. So while this is solved, let me explain the question in a more mathematical manner, which means that whereby, let's say, assuming that we are finding it difficult to let's say do this manipulation, right? Let me explain that as well for you. So this is done. However, just for the case, if you get such a question and if you are not able to identify what hidden trial process is required, so this is what you should do, what needs to be done, right? You need to assume what constants should I with what constants we need to multiply the given equations, right? And then find those constants by the mathematical condition, which is based on the expression you need. You need the value of x plus y plus z. So the coefficient of x and y and z should be each 1, right? So on doing this, first equation into m plus second equation into n, basically you get a single equation, which is that 5m plus 6n into x, right, plus 6m plus 4n into y plus 7m plus 2n into z equals 178m plus 124n. And then you put the constraint that we need the coefficients to be 1 for all the three variables. So 5m plus 6n, 6m plus 4n, as well as 7m plus 2n need to be 1. It is not always necessary that m and n can always be possible, right? Because now we have three equations in only two parameters, m and n. So what you need to do is solve any two equations, get the values of m and n from there, and then do a verify check that do those values of m and n also satisfy the third equation. If they do not satisfy, then the answer to the question is cannot be determined. Else, those values of m and n justify, and the required answer is the value of this expression on the right hand side. So this is the more mathematical way, but as you can see and as you observed, that hidden trial was obviously a better one, but it may or may not strike. So if it strikes in few seconds, good, done. Else you can do this process. All right. So I hope you're finding this interesting, and let's see the next one, the second question. All right. Now let me see if I can get a response on this question. If somebody can crack this one, right? Giving you 2 minutes to think on this. All right. So let me know if you're getting this. Let me start the discussion. We have three people who went together to a stationery shop, and you can see that in the statements we are talking of four things now. And once again, we have only two informations about that, right? Pencils, pens, erasers, and sharpeners. Two of them, the purchase combination and amount is there. We have to find the value for the third person. Let's see. So a similar kind of question, but with more variables. Let's say we take W, X, Y, Z as the cost of pencil is W, pens is X, erasers y, and sharpeners are z, the cost of each item. So our equations become that 9w, 8x, 6y, and 10z is 241 is my first condition. And second one is that for Kunal, 6 pencils and 12 pens, so 12x, 4 erasers, 4y, and 15 sharpeners is 294. From these two conditions or equations, we need to find the value of this expression. For Krish, we need to find the value of, over here I'm writing 12 pencils, 12x, 12w, 4x, 8y, 5z. This is how much. Now, so there is obviously a challenge. 4 variables, only 2 equations, and we need to find something. There is still an option of cannot be determined. Well, so in this problem, coefficients play a major role. You should try to observe that amongst the two equations, if you are able to figure out or find that the ratio of the coefficients is the same for certain variables. For example, let's search for that. W and X, so 9 and 8 here, 6 and 12 here. The ratio is not the same. But W and Y, 9 and 6 is 3:2. 6 and 4 is also 3:2. So in the two equations, W and Y, these two variables are bounded by the same ratio. And by chance, if you look at the other two variables, which is X and Z, so 8 and 10, 4:5, 12 and 15, 4:5. Very nice, very wonderful. Those other two variables are also bounded by the same ratio. So here is something what we can do. Let me call this a bundle approach, right? Which means that I can make a bundle of, let's say, based on the ratio of 3:2 between the coefficients of W and Y, and I can make one bundle, let's say bundle A, which is comprised of 3 pencils and 2 erasers, 3W plus 2Y, right? So Kabir has bought 3 such bundles, whereas Kunal has bought 2 such bundles. And another bundle B, let's say, of bounded by the ratio of 4:5, 4 pens, 4x, and 5 sharpeners, 5z. So now my system of equations in this structure get reduced from 4 parameters to only 2 parameters, which are these 2 bundles. And if you look at the target expression carefully, then you see that in that target expression W and Y, 12:8, still 3:2, and X is to Z again 4:5. So we can find the value of that. We know that now. The answer can be obtained, right? So coefficients play a very huge role in such problems. Try to search for the fact that whether the coefficients are in the same ratio, then you can reduce the problem to less number of variables. So therefore, the first equation can be rewritten as 3 bundles of A and 2 bundles of B, right? 3 bundles of A and 2 bundles of B, right? They equal to 41. Whereas for Kunal, 6W plus 4Y, so 2 bundles of A, 12X and 15Z, so 3 bundles of B, they equal 294, right? Now let's solve this, right? And then what we need is basically 3 bundles of A, 12W plus 8Y. Sorry, that is 4 bundles of A. We need a value of 4 bundles of A, 12W and 8Y, and 4A and 1 bundle of B. That is the value that we need. So obviously we can find this, right? Okay, so just solve as usual. Over here, I'm multiplying with 3, multiplying with 2 over here. So first equation, 9A plus 6B is right 723, and second equation into 2 becomes 4A plus 6B is 588, right? And then subtract, so 6B cancels. We are left with 5A is 723 minus 588, which is 135. So A has come out to be 135 by 5, which is 27. And put it back in any equation. So come back to the first equation over here. 2B is 241 minus 3A, which is 81. So this is 160. So 160 upon 2b is 80. Perfect. So b is 80, a is 27. So the answer is the value of 4a plus b, which is 4 into 27 is 108 plus 80 is 188. Perfect. So don't jump to answering cannot be determined in such problems, right? So these kind of questions have been asked, and this kind of complexity can be expected. All right. So now let's come back to some interesting word problems. Something on ages. We took some age problems in the last session as well. And again, let me see if I can get some response over here. Giving you a minute to think on this. Now, so from the last session, you might recall the approach that we have taken on age problems, right? We mostly are comfortable in tabulating the information and writing all the expressions for the ages in past, present, future, whichever things are required. In this question, if you look at carefully, there are three people, and we are talking of both present, past, as well as future, because 4 years hence is the statement over here. So that is future, and 2 years ago, so that's past. Now, always we try to start from the present, means trying to define the variables or the ages in from the present and then trying to proceed further, right? So let's start. We have Amog, we have Bhairav, and we have Chaitanya. Perfect. So we start from the very first statement. The ages of Amog and Bhairav are in the ratio 3:2. So in right now, right? So we are talking right now the present, obviously. So we'll first of all define the ages based on 3:2 as 3k and 2k, right? Let that be the starting point. Chaitanya, let that be a third variable. Let's say some x, right? Let's put it like that. Because Chaitanya, as such, nothing is given, but he's mentioned in the further statements. 4 years hence, 4 years from now, the ages of Amog and Chaitanya are given to be in the ratio of 2:3. So let's write the equation for that, right? For Amog and Chaitanya, I'm just directly writing the equation 4 years hence. So Amog will be 3k plus 4 in age, whereas Chaitanya will be x plus 4 in age. So this ratio 3k plus 4 over x plus 4 is given to be 2 by 3. Let's simplify this. Cross simplifying. 9k plus 12 equals 2x plus 8, right? 9k plus 12 is 2x plus 8, or finally 2x equals 9k plus 4 is my first equation I got, right? Perfect. 2 years ago. Now coming to the past and writing for Bhairav and Chaitanya, the other information. 2 years ago, Bhairav will be 2k minus 2 in age 2 years ago. He's right now 2k, and Chaitanya will be uh, simply x minus 2, and this ratio is 1:3, right? Again simplifying. So basically we can see now the problem is we can see that we have two variables x and k, and we are now going to equations. So I think we'll get everything from here now. Cross multiplying. 3 into 2, 6k minus 6 is x minus 2, which means that we can say x is 6k minus 4. So let's say we can equate the value of 2x from both. So 2x equals 9k plus 4 from the first equation, which also should equal double of this from the second equation over here, right? So double of this, which is 12k minus 8. Perfect. So 12 minus 9, which is 3k, equals 4 plus 8, which is 12. So k has come to be 4. Perfect. And therefore x, which is 6k minus 4, becomes 6 into 4, 24 minus 4, x is 20. Perfect. So therefore, now question is, how after how many years will the ages of Amog and Bhairav be in the ratio of 6 is to 5? Amog is right now 12 years. Bhairav is right now 8 years. So 12 plus some number of years, let's say n, and 8 plus some number of years, let's say n, this ratio should be 6 by 5. Now it's better to go to the options instead of, we can also solve the equation equal to 6 by 5, or just start putting from the options. So if I put option A, I'm expecting a ratio of 6 is to 5. Now, so 12 plus 10, 22 over 10, 8 plus 10, 18. So that's not a ratio of 6 is to 5. Putting n as 8, 12 and 8, 20. I don't think so, because we need a factor of 3 in the numerator. Forget that. Option C, 12 plus 12, 24. Looks good. 24. Multiple of 4, 6. Denominator 8 plus 12, 20. Yes, that is exactly what we wanted. This is 6 is to 5. Right. So I think it's a pretty good question whereby both past, present, futures were involved, and everything was given. It seemed initially that everything is given in terms of ages. How can we find some number? But the point is that these time which we are going forward and backward, those are the numbers which play a role in being able to solve the question. Perfect. Okay, next one. Another age problem. Let's see this. If you can get this one. It's almost a mind-boggling statement, isn't it? This one. But that is the catch. How to interpret this statement? All right. So let's try to decode this. We are given that Aman tells Ram. Now, this is the most crucial thing to understand this. I am half as old as you shall be when I shall be as old as you are. First of all, from the statement, it is very clear Aman is younger than Ram, because Aman needs to wait for some years to become as old as Ram. So obviously, Ram is right now older through Aman. Okay, that's a qualitative thing, but we're looking to analyze this mathematically. How much is the present age of Ram? Now, the question asks something further. Present, how much is the present age of Ram compared to the age of Aman when Ram was as old as Aman is? The statement made by Aman transcends to the future. The question itself takes us back in the past. Okay, so let's see. Right, try to define. So everything is in here in this state, in this problem, is in ratio form, isn't it? So we should, our objective is not to find some numbers. We cannot, there's nothing given in terms of number of years, anything like that. Everything is in ratios, right? So from the statement of Aman, we are doing something about present and then future, right? So let's try to write the expressions for the ages. I am half as old as you shall be. Present of Aman is half of what Ram will be in the future. This number is half of this number, or other way around, this number is twice of this number. Make that interpretation. So if this is some x, then this is 2x. I am half as old as you shall be, comma, when I shall be as old. Now he's talking of his own future, as old as you are with the other person's present. Means these two are equal. So this is, let's say, some y, this is, let's say, some y. Can I say this is the meaning of the statement? The mathematical way to express this statement, right? This is half of this, and these two are equal. Now, we have to relate x and y. How? How can we relate x and y? In any age problem, the only thing is age gap between any two people always remains the same. You have the ages in the present and the future in variable x form. Just write the equation that the age difference between them is same. Obviously, Ram is more than Aman. So Ram minus Aman, which is y minus x from the present, should also be equal to 2x minus y from the future. So we are able to express from here 2y equals 3x, or x upon y is 2 upon 3, right? X upon y is 2 upon 3. So we can take x as 2k and y as 3k. Yes or no? Now coming back to this, therefore, if I do that, then this is 2k, x is 2k. So this is 2k, this is 4k, and y is 3k. Now this is the way we can, basically we have been able to express the ratio of the ages both in present and future for the two persons. Now comes the question. How much is the present age of Ram? The present age of Ram is 3k as compared to the age of Aman when Ram was as old. Ram was as old as Aman is. Ram is 3k right now. He needs to be as old as Aman is, which is 2k. So from 3k to 2k, we are going k years in the past. So in that past that we are talking of, when Ram will be 2k, so we are going minus k years. So 3k minus k. So Aman also 2k minus k, which is k years. So Ram is 3k as compared to the age of Aman when Ram was as old as Aman is. At that point of time, Aman was k. So the answer is thrice. How much is the present age of Ram? 3k as compared to the age of Aman, which is k. When Raman was as old as Aman, Ram was as old as Aman is. Wonderful. No numbers involved, but pure interpretation skills were required. Ratios were, we were only working with ratios. Perfect. All right. Next one. So something very interesting once again. A kind of question which requires good analysis. Let's see if you can do this. Okay. Let's discuss. At the Akshardham temple, visitors can either buy the ticket for the musical fountain only, or boat ride only, or a combo ticket for both. So if I'm going to the musical fountain, I might have bought the only musical fountain ticket or maybe a combo ticket, right? One day, 60% more tickets were sold for musical fountain only than boat ride only. But 25% more people visited the musical fountain than the boat ride. Okay, it makes sense. Or, I mean, I think this is quite possible because of the fact that the number of people visiting the musical fountain ride is not the same as the number of people who have bought the ticket for musical fountain only, as we just said, right? Okay. So there are three categories of persons or ticket buyers: those who buy for musical fountain only, those who buy the tickets for boat ride only, and those who buy the combo tickets, right? So the first statement about 60% gives us the relation or the ratio of these first two categories. So 60% more means 1.6 times 1.6 in fraction is 8 by 5. So it defines a ratio of 8 is to 5 between these two. So if this is 5k, then this is 8k number of ticket buyers of these categories. Let's say that the combo ticket buyers is some other parameter x, right? And then further from the second part of the sentence, 25% condition, we should be able to relate x and k now, right? And I think that will finish the problem for us. So 25% more people visited the musical fountain than boat ride. So how many people actually visited the musical fountain? The the people who bought the first and the third kind of tickets, right? So therefore, the total number of musical fountain visitors is 8k plus x. And likewise, the total number of boat ride visitors are again the second and the third categories together 5k plus x. So these two are related such that the numerator is 25% more than the denominator. So it is basically 1.25 times of that. So this ratio is 1.25, or in simplest ratio or fraction form it is 5 by 4. 1.25, 5 by 4. So I think now we should be able to simplify this and relate x in k. Let's do that. Cross multiplying 8 into 4, 32k plus 4x is 5 into 5, 25k plus 5x. So I'm getting 5x minus 4x, which is x, is 32 minus 25, which is 7k. Perfect. So this is 7k. So question is then asking, if each visitor to the temple bought at least one ticket, it means there is nobody who did not buy any of the tickets. So everybody is here in these three categories. Means the total number of visitors, can I say, to the Akshardham temple is the sum of these three: 8 and 5, 13, and 7, 20k. Then what proportion of the visitors bought the combo ticket? So that's now in front of us: 7k out of 20k. So that's a ratio of 7 by 20 simply, which is a percentage of 7 by 20 into 100, or yes, 7 into 5, 35%, right? 35% visitors bought the combo ticket. So today we are discussing questions which are not just pure algebra, but a lot of thinking and reasoning skills are involved. Being able to interpret the problem statement itself is the challenge. That's the theme for today, right? And uh, so I hope this is making sense, and this is that you are able to understand that algebra is not just about variables, equations, and solving them. The process of creating variables and framing the equations is the real challenge. If I mean, if you look at the questions which have actually been thought provoking, right? Okay, so in that spirit, the next question I hope you would love looking at, trying, and letting me know if you can get this one. Let's see this one. It says that four steel balls have distinct weights. The total weights of all possible pairs of balls were noted down. The total weight of all possible pairs of balls were noted down. It means that we did not weigh the balls one at a time, but rather we paired other balls and we noted the total weight. And amongst the six pairings, so he's telling you there must be six pairings. So yes, indeed, if we have four balls, we can take six different pairings, right? For example, if I define the four weights of the balls, let's say as A, B, C, D, and also let me put that in a certain order, because you can understand that we have to try to solve for these weights clearly, right? Let A, B, C, D be in the ascending order. Let A be the smallest weight, D be the largest weight. Then what will be the combinations? Six combinations: AB, AC, AD, BC, BD, CD. Six combinations, right? So he's saying that amongst them, two pairs had the same total weight. Okay. The distinct weights of the pairs noted were 39, 46, 49, 52, and 59. Five values are given. So although we need six values, but only five are given. So he's saying, if indirectly, or in fact, he has told us directly, two pairs had the same total weight. So one of the values will repeat, right? There are two pairs of balls, two different pairs of balls, which weigh the same. So for example, maybe something like A plus B equals C plus D. And that is why he's giving us five of those six. I mean, all the six numbers we know, but of them, two will repeat. So five of the values are given to us. Now, the challenge is to be able to interpret which two combinations of weights could have been the same, and then which could be the number from amongst those given to us. That's the challenge. And the question asks us for the difference of the weight of the highest and the heaviest and the lightest ball. So let's start thinking on this. Okay. The reason you can understand why I have assumed the variables in a certain order, because then I can start writing equations around that. Now, first thing, which two weights could be same? Obviously, let's fix A as one of the pairs, right? One of the pairs, let that have the ball A of weight A. So could A plus B equal to C plus D? Never. A and B are the two lightest balls. They can never equal the sum of the two heaviest balls. Never possible. Could A plus C equal B plus D? Again, impossible, because both the balls are correspondingly lighter than the next balls. So A plus D can never be equal to B plus D. The only combination, therefore, which makes sense is that A plus D, the lightest and the heaviest, could equal the second lightest and the second heaviest. That is the only possibility, right? Now comes to decoding these numbers and matching them to these four uh, values. Obviously, A and B are the two lightest balls. Their sum of weight should match up with the lightest number, which is that we can write the equation that A plus B must equal 39. Then A plus C should be the second lightest combination of pairs of balls. So therefore, A plus C must equal the 46 given to us. Next, as we have already discussed, A plus D and B plus C. Now, which value they should take? Now, the way we have written equations for A and B, A and C, we can also write the equations now for the heaviest balls. So first, let me write the equation that the two heaviest balls C and D must equal the the largest value, which is 59 kgs. So C and D is the two heaviest balls. The next second heaviest combination must be obtained likewise by replacing C with B, right? So B plus D must be the second heaviest combination of 52 kgs. So having written these four combinations, it makes perfect sense for us to now conclude that it is this middle value 49 which must be linked up to the A and D or B and C, right? So A plus D equals B plus C equals 49. Now we have these equations with us, a lot of equations to solve for the four variables. In fact, we have actually now 5 equations in 4 variables, right? You might be wondering, we have more information than we need, but actually that is not the case, because if you look at the only the first 4 equations, they are not independent of each other, because the first and the second equations added up also give us the value of A plus B plus C plus D, and the third and fourth equations when added also give the same value, right? So if you try to solve the 4 variables using only the first 4 equations, you will keep on going round and round. You will never be able to solve the equations as such. Okay, now let's try to freeze this problem. Let me look at the first equation, A plus B equal to 39. And what I'm trying to think now, with this A plus B being equal to 39, let me try to write A and B in terms of a single variable from the other equations. If I can do that, then I can solve this, right? And let me say from the second equation, let me write A being equal to 46 minus C. Okay, makes sense. So with that, my thought is, let me try to write A and B both in terms of C. And I can do that from the second equation, and from the fifth equation, you can see B plus C is there, right? So therefore, B can be written from this fifth equation as 49 minus C. And therefore, yes, we now have the value of a single variable. I think we can get from here. Perfect. 46 and 49, so that is 95 minus 2C equals 39. 95 minus 39 will be 56. So 2C is 56. C has come to be 28. Perfect. So now it's just solving the equations, right? But the framing process of these equations and being able to understand that why the which pair should be equal, A plus D equal to B plus C, and what it should match up with what value. It should match up with 49 for sure. That was the core logic of the problem. Now just finishing off the problem, C is 28. So put it back anywhere. A from here is 46 minus C, which is 28. So this is 18. Lightest ball has come to be 18. Perfect. Can we find D? Let's say from the third equation, yes, we can find that. D therefore is 59 minus C, which we have got as 28. So this is coming to be 31. So therefore, this difference is what we're looking for, which is 31 minus 18, right? So 13 kg. So I hope this was quite an interesting one, and makes, I mean, quite a logical problem, right? Makes us think a lot. Okay, let me take some illustrations from the previous years now. Uh, so this is related to the first two questions that we took today, CAT 2016. So it's quite on the similar lines, where you can see that there are three parameters and two equations, and we are asked then to find something, right? So let's go ahead with this one as well. The total cost of, so let's say pencils are X, erasers are Y, sharpeners are Z. So first condition is that 2X plus 5Y and 7Z is 30. Perfect. While 3 pencils, which is 3X, 5 sharpeners. Now, 5 sharpeners, be very careful. Sharpeners are 5, they are Z, right? Now, this is not a sum equation. The equation is 3 pencils and 5 sharpeners, which is 3X plus 5Z, cost 15 more than 6 erasers. Means this equals 15 plus 6Y. So if I'm writing plus 6y here on the right hand side, I can bring it on the left hand side, and I can write over here minus 6y. So this equation effectively, right, I like keeping variables on one side and constant on the other, gives us this, right? 3x minus 6y plus 5z is 15. Now, so with these, what we are trying to find, first equation, second equation, using them, we are trying to find what our target is. By what amount does the cost of 39 erasers, which is 39y, and one sharpener, which is z, exceed the cost of 6 pencils? Means 39y plus z equals 6x plus what? Or bring 6x over here, minus 6x equals what? Right? 39y plus z minus 6x is what? Or writing in the same order, minus 6x plus 39y plus z is how much? This is effectively what you're looking for. Now try to do that hidden trial process that we discussed. Now 39 being the largest coefficient, let's target achieving that. Okay, let's target to, I mean, what I'm thinking is some multiple of 5, and let's say adding to some quotient of some multiple of 6 gives us 39. One of the possibilities I can think of is that 5 into 315, 5 into 315 plus 24, which is 6 into 4, 24, equals 39. Now, I should be able to match these coefficients with the other requirements as well. I just not only need 39y, but I also need 1 of z and minus 6 of x, which is, I have taken the coefficient, I mean, I have multiplied the first equation with 5, can I say? With 3, can I say? Right? 5 into 315. And I have multiplied the second equation with 4, right? 5 into 3, 15, 6 into 4, 24. And I have subtracted the two equations, right? 15 minus of minus 24 is 39. Now, does that also give me 1 of z? 7 into 3 is 21. 5 into 4 is 20. Yes. Yes. We get 1 of z. Looks good. Does x also match? 2 into 3 is 6. 3 into 4, 12. 6 minus 12 minus 6. Perfect. This is exactly what we need. Yes. So yes, our first hidden trial process has been successful. Minus 6x plus 39y plus z therefore equals 30 into 3 minus 15 into 4, which is 30 into 3, 90, minus 15 into 4, 60 is 30, right? So if this strikes well, good. I mean, so you can see that little bit effort was obviously required, right? 39, I found 39 to be a convenient number to attack. Reason being, it's a large coefficient. So how it can be obtained as the sum of multiple of 5 and 6, uh, right? If I can navigate through that, and most likely it should fit the others also, which it happened. If that does not happen, if your hit and trial does not work out, I have always given you the proper mathematical approach. Let's look at the next one. Cat 24 problem. So actually this is quite, I would say, a routine problem that appeared. uh, just my intention of bringing this problem was to discuss the idea that how we can solve the problems through multiple approaches, right? In this, you see there is a sequential chain of events happening repetitively. A shop wants to sell a certain quantity in kilograms of grains. It sells half the quantity and an additional 3 kg of these grains to the first customer. And then the problem goes on to repeat this process for the second and the third customers. The same process. Give half and 3 more, right? And finally, there are no grains left at the end of the giving the grains to the third customer. So what's the initial quantity? It's a very usual problem. The the first instinct of any person would be to take x as the initial and create an equation around that. No harm with that, and I will solve from that approach also, and I will give you the alternate approach also. First, let me solve from the routine mathematical approach of creating the variable. If we start with x, so at every stage our focus is on what is remaining, right? We are not focusing on what we are giving, but more on what we are remaining with, because it is the remaining quantity is the one with which we are further distributing in the next, for the next customer. So if we start with x kilograms, first we give half, so we are left with half. We give 3 kg more, so we are left with 3 kg less, so minus 3. So after giving to the first customer, this is the remaining quantity, x by 2 minus 3. Then with this, we further give half of this, so this in brackets, and then we give half of this, so we are left with half of it, and then we give 3 more, so we are left with 3 less. So half of this whole expression minus 3. Second customer we have given, and this is what we are remaining. Again, this is the in whole brackets the remaining quantity. Again we give half of this, so we are left with half of it, right? And we give 3 more, so we are left with 3 less, minus 3. And finally we should be left with nothing, so this should equal 0. So just proper systematically solve this equation, single variable linear equation, you should get the answer. Not a hassle, get the answer, right? This goes over there equal to 3, right? So let me solve here and now just by doing cancellations and all, right? This goes over there, so this is equal to 3. This 3 into 2, 2 comes over here, so this is 6. This minus 3 comes over here, so minus 3 comes over here. 3 plus 6, this is 9. And again this 2 comes over here, so 2 into 9, so this is 18 on the right hand side. And again finally this 3 comes over here, so 18 plus 3, this is 21, and 21 into 2, 42 is the answer, right? So not any which way challenging problem, but the only thing is that there could have been a mistake done in solving this equation. You see, whether you sometimes confusion can, I mean, sometimes in when we are in a hurry, right? We are solving quickly. Sometimes we forget. Okay, it's not minus. It's sometimes what we can do the mistake of multiplying with 2 before transferring 3 on the right hand side. That's the only mistake that can happen, right? The alternate approach is to start from the, I mean, to look at what happened at the last and just backtrack the thing, right? So just solving this question mentally can be done. No variables, nothing I will write. Just erase everything, right? Just clear everything, and just can be solved in the mind, which is, so last customer, when I gave 3, I was left with nothing. So just prior to that, I should have be having 3 kg. Now that 3 kg should have been half of what I had to start with, because this 3 should be half, isn't it? So therefore 3 plus 3, 6 is what I was having at that stage, right? And that 6 therefore is what was remaining after I came from the second customer to the third customer. So 6 was the remaining. Now, so prior to that, I had just given 3 kg more to the second customer, and then I was left with 6 kg. So 6 plus 3, 9 is what I should be having in my hands at that stage, and that 9 represents half of what uh, was there with me before giving to the second customer. Right. So that 9 is half. So therefore, 9 plus 9, 18 is what I had with me before going to the second customer. Means after coming from the first customer. So that 18 kg is what I had with me after coming from the first customer. And I had just given 3 kg to the first customer. So 18 plus 3, 21. And that 21 is half of what I started with. So 21 into 2, 42. Right. So can be solved mentally if you can understand this backtracking process also. Right. So algebra is not always about variables and creating equations. It's just about observation skills. Now, let me take one last problem for today's session with this ZAT 2018 problem. Let's see. In the final semester, an engineering college offers 3 elective courses and 1 mandatory course. A student has to register for exactly 3 courses, 2 electives, and the mandatory course. The registration in 3 of the 4 courses is given. What will be the number of students in the elective with the lowest registration? There are in total 4 courses, 3 electives, 1 mandatory. You have to take 2 electives and 1 mandatory. Let's just name the 3 electives as A, B, and C. Let's say these are the 3 electives. And let's say D is the mandatory course which will be taken by all. Now focus on these numbers and what do they denote? You see that there are combinations of electives which can be taken, right? We have to take 2 electives and 1 mandatory. So everybody has to take D. But electives can either be taken as A and B and then D, or A and C with D, or B and C with D. So there are 3 combinations of these electives. So it is very obvious and it makes perfect sense that the people who are joining these combinations of courses are unique persons, and they represent, so therefore there are 3 categories in which the whole population of students is being divided. Let's just call these students as X in number who join the electives A and B along with D. Let's just call that there are these Y students in number who join the courses A and C electives with D, and Z over here who join B and C electives with D. So it is very clear and obvious that X plus Y plus Z represents the total number of students, and since all the students must join the mandatory course, so this also represents the number of students who have joined the course D. Right? Makes sense. Now we are looking for the number of students in the elective with the lowest registration. All right. Now we don't know that these 3 courses which we are talking about, the numbers 45, 55, and 70, do they include the mandatory course also or not? If you think carefully, then nowhere it is mentioned that whether these 3 courses are all 3 electives or they are 2 of the electives and one and the mandatory course. So you see there is a, if you see the options, right, there is an option which talks about 2 possibilities, either B or D. So we must analyze the problem from that angle, that there might be 2 possibilities over here. So there are 2 possibilities in case 1. Let us assume that, or let us take the case 1, when you see if if mandatory courses amongst these 3 courses mentioned, then obviously it must be the one with the highest number, because the other 2 are sub parts of that, right? So 70 must be the value of, can I say, D, which is X plus Y plus Z, right? Which means what I'm saying is that mandatory course is included in the given data. So therefore, X plus Y plus Z is 70. Now, In three of the four courses, it's 45, 55, and 70. So let's just call for the convenience sake that the course A is equal to 45. And can I say A is represented in by the students X and Y, right? So X plus Y should equal our 45. And likewise, let us assume that the course B is 45 students. So B is represented here in X by students X and Z categories. So X plus Z equals 55. Now we are trying to find the number for C over here, the course C, right? So course C is the value of Y plus Z. So we are trying to find the value of Y plus Z. Okay, so let's do that. I think we have three questions from the above. We can solve that. Uh, if I add the equations for A and B, then I'm getting that 2x plus y plus z is 45 and 55, which is 100, right? I'm trying to find y plus z. So to eliminate x, let me from the first equation double that so that I can eliminate x. So I can obviously get 2x plus 2y plus 2z is 70 into 2, 140. So subtracting that gives me the value of y plus z as 40. So that is one possibility, can I say? It is possible because 40 is a number less than 70. It is the only condition that we need to satisfy is that the number, all the three remaining numbers should be less than 70, right? And they should be integers. All that is met. Case 2. Case 2 is when these three numbers are electives only, right? The data of electives is given. If that is the case, then as we can understand that A, B, and C courses are represented by the combinations of these three students X, Y, and Z, right? So let me assume that A is 45, B is 55, C is 70. So we can write the equation very quickly. A equals X plus Y equals 45. B equals uh, right X plus Z, which equals 55, and C equals Y plus Z, which equals 70. Now we are trying to find the number for mandatory course, which is the value of x plus y plus z. So obviously you can just add these three equations, and by symmetry you can understand we are getting twice of x plus y plus z by adding, right? X, y, y, z, z. 45, 50, 100, and 70, 170. So x plus y plus z is coming to be 85. Makes perfect sense. 85 is a number larger than all these three numbers. So that condition is satisfied. And the smallest number of students in the electives with the lowest registration is obviously the 45, which was given to begin with, right? We did not solve for it. It just was already there. So yes, it makes perfect sense that the course with the lowest registration from the case one, where the numbers came out to be 40, 45, and 55 could be 40, or it could be 45 from the second case. So yes, either 40 or 45, which means either B or D, right? So I think you can understand that how, again, we had to carefully understand and interpret the data to be able to reach to the conclusion with this problem, right? So I hope this was something that makes us familiar with the kind of work that we have to do with algebra also. Perfect. So feel free to drop in your comments, your suggestions. I'll be looking forward to seeing your response, right? Please feel free to ask anything with me on the chat box, on the comment section. Next session, CDC Pro analysis. That's for tomorrow, a session not to be missed, right, by all our mentors. CDC Pro 1 mock analysis. Tune in tomorrow at 8 p.m. Right, and as you know that our test series is live starting from 999, right, and our MBA Blackie batch is all there and available, and you should uh, if you find that relevant, I would say suggest that that is the one of the best options that you have, right? So thank you with this. So see you in the next session on algebra. Thank you so much. Thank you.